here at the Digital Twin Consortium, we've spent a long time thinking about this, collaborating with a lot of our colleagues across numerous organizations around the globe. And the key elements that come out of the definition of digital twin that we published a couple of years ago now are this concept of a virtual representation, the significance of the real world, and the importance of synchronization. And let me dive into that briefly in terms of the definition, because this is quite key in terms of what are the key building blocks that we then derive. This is the definition that I'm sure many of you are familiar with. A digital twin is a virtual representation of real-world entities and processes synchronized at a specified frequency and fidelity. You can already see this, those key elements that I pulled out on the previous slide in terms of the representation, the real-world entities and processes, and the synchronization. We can then step through and talk about the importance of impact, importance of application, and realizing that value by transforming businesses and effective action. And we'll see this through the use of applications and so forth in the framework. Then we build on that and say, hang on a minute, how can you have a digital twin without data? And we have real-time data, we also have historical data, and we pull those two separate pieces out into two separate elements within this framework. And that's going to be quite significant as it defines part of the right-hand side of the model. And then again, emphasizing the implementation, you can't have a digital twin without having somewhere to run it. I wouldn't be able to be here with you in this webinar without running on some IT system. And easy to forget, but an important part when we come to designing these architectures is the IT and the OT, the operational technology systems involved. So what we're gonna do is we're gonna pull each of these elements out and understand that the key constituent parts of this are that virtual representation, the need for synchronization, the importance of data, and the IT, and so forth. This leads us to a simplified framework that you can see in this funnel diagram here, where we have applications and services. We recognize the challenges and the importance of integration and interoperability, which also will include the elements of synchronization that we'll get to later through the service interface layer. And then at the heart or the core, depending how you want to define it, we have the virtual representation. And this all runs on IT, OT platforms. So hopefully you can see that this maps directly back to the definition. And this is all about ensuring consistency in language, consistency in the semantics as we're talking about these systems, so that when we're explaining what digital twin is, we can map that all the way through to the architecture, the implementation, the deployment, so that all stakeholders are consistently using the same language as we go through this. One of the separate activities that we've been doing at the Digital Twin Consortium, you can also find a glossary on our GitHub site, which goes through a lot of the terminologies and adds definitions to each of these. So do feel free to go and have a look at that as well. Let's expand on that funnel, that simple diagram with those 4 layers, where we have applications at the top, we have those service interfaces, then we have virtual representation, and it runs on IT, OT platforms. We can expand this into these layers. So again, we have applications sitting at the top with integration service interfaces, with the virtual representation, IT, OT platform. We also introduce here 2 additional really important concepts, one being the real world. And if you remember back to the definition, a digital twin is a virtual representation of real-world entities and processes. So if we don't account for the real world in this architectural framework, we're completely missing the point. And if we want to be able to rely on these systems, on the predictions, the forecasts that digital twins are used for, we have to be able to trust it. It has to be secure, it has to be governed, it has to be managed. And we have to take that into account as well.